All right, for this first part of lesson 3.1, we are going to review how to solve a 2 by 2 system of equations by graphing. So again, review from Algebra 1. You should hopefully recognize this once we start doing it because it is something you learned then. So we are just going to be working through example 1 on this video. So part that's new that I'm not sure was in Algebra 1 are the names of the classifications. So in your homework on, quiz, stuff like that, you will need to know these classifications. So I put them here on your notes so that you'll have them there to study. So a system can either be consistent or inconsistent. It can't be both. It's consistent if it has a solution at all. It's inconsistent if there is no solution. Now, these two subcategories, the independent and dependent, these guys are only for consistent systems. So if a system is consistent, then it's either independent, meaning it has one solution, or it's dependent, meaning it has infinitely many solutions. So if a system is inconsistent, it does not get this subcategory of independent or dependent. It only gets inconsistent. Okay, so the first thing that we need to do is we need to graph each of these equations, and we've spent a lot of time in the past couple weeks reviewing how to graph linear equations. So as I've mentioned many times before, you can choose to graph these however you want to choose to graph these. So if you feel like finding intercepts is best, do that. If you feel like using slope-intercept is best, do that. If you feel like finding a t-chart is going to work best for you, that is a choice you can make. So I'll try to do kind of a variety here so that way we review all the methods again. So first line up here, the 4x minus 3y equals negative 15. This one I'm going to make a t-chart for because the y and the x both have numbers in front of them, so it just seems like it might be a little bit easier if I pick some x's and find some y's to go with them. So the first x I'm going to pick is a negative x just to see what happens. So I'm going to pick negative 2. So if I put negative 2 in for x, that gives me negative 8 here. So I get negative 8 minus 3y equals negative 15. So if I add the 8 to both sides, I get negative 3y equals negative 7. So that gives me 7/3. It doesn't come out real nicely for us, but that doesn't mean that we can't plot it. 7/3 is going to be in the coordinate plane without having to change the scale, so that's good. So now I'm going to try negative 1 and see what happens. So 4 times negative 1 is negative 4. So I get negative 4 minus 3y equals negative 15. If I add the 4 to both sides, I get negative 3y equals negative 11. So that's going to give me 11/3. So again, doesn't come out evenly, but that's okay. We can still use it. Next, I'm going to pick 0. 0 is the easiest thing to plug in. So if I plug 0 in here, I am going to get negative 3y equals negative 15, which if I divide both sides by negative 3, that does come out evenly. I get 0.5. So then, because a 2 and a 1 didn't come out evenly, I think the next one I'm going to pick is a 3, just to see if multiples of 3 come out evenly. And again, you can pick whatever you want. So 4 times 3 is 12, so that gives me 12 minus 3y equals negative 15. So if I subtract the 12 on both sides, that's going to give me negative 3y equals negative 27. Which does come out evenly, but it's 9, which is going to be bigger than what we want if we don't want to change the scale. So we've got a couple points here that we could definitely plot that would give us, something, and we can choose to change the scale if we want, but probably we don't want to. Okay, now I'm not going to plot these points yet because my advice is always to do both lines before you decide upon a scale, because the worst thing is plotting the first line and then realizing you have to change the scale for the second one. So this one I'm going to use by getting y alone because it's relatively easy to isolate here. So I'm going to subtract the x on both sides. So that gives me 2y equals negative x minus 1. And then I'm going to divide everything by 2. So these cancel, and I get y equals negative 1/2 x minus 1/2. Okay, so these I can both plot on the scale that I have. So I'm going to do the blue one first since I'm already on the blue color. So y-intercept at negative 1/2, so that's right here. And a slope of negative 1/2, which means down 1, right 2. Down 1, right 2. Notice I'm staying in between because that's where my y-intercept was. And I can also go up 1, left 2, up 1, left 2. Generally, you want to make marks as far as you can until you're off of the screen. And again, sorry that this line will be kind of curvy because I can't write on this flat and it's kind of difficult to do. So there's our first line. Now I'm going to go back to my red line and I'm going to plot those points. So negative 2, 7/3. 3 goes into 7 twice with 1 left over. So that's 2 1/3. So negative 2, 2 1/3. It's right here. Then negative 1, 11/3. 3 goes into 11 9 times, or 9 goes in 3 times. It is 9 with 2 left over. So 3 and 2/3. So negative 1 and then up 3 and 2/3. And then 0.5, which would be right here. Connect my dots. And I've got both my lines graphed. Now, hopefully you remember from Algebra 1 that when we are estimating the solution, that the solution is the intersection point. So write that down so that you won't forget. This is our intersection point. So the way it looks right now on what we've drawn is it appears that our intersection point is the point -3, +1. Now it says check the solution, which means we want to plug it in and make sure it works. So if x is -3, -3 plus 2 times 1 would be -1, so that works. 4 times -3 is -12. Minus 3 is indeed -15. So we have checked it. It works in both. This is our answer. So now we just classify it. So consistent or inconsistent. In this case, it has a solution. So we'll say consistent. And because it's consistent, we then need to say independent or dependent, which there's only one intersection point here. So we will say it's consistent and independent. And we are done with that one. Okay, moving on to part B. Let's use maybe green here. So I did slope-intercept, I did a t-chart. This top line here I'm going to do with the double intercept method. So I'm going to find both intercepts. So the x-intercept, remember I plug in 0 for y, so 2x plus 4 times 0 equals 12. So that gives me 2x equals 12, which means x equals 6. So my x-intercept is going to be at 6, 0. On this green one, my y-intercept, I'm going to plug in 0 for x. So 2 times 0 plus 4y equals 12. And so that gives me 4y equals 12, which means y is 3. So my y-intercept is going to be at 0, 3. Again, I suggest waiting to actually graph them until you've done both lines. So I've got 6, 0 and 0, 3 as 2 points on that top line. So then I go down to my bottom line here, and again, because the x is by itself, it seems relatively easy to get the y alone, so I'll do slope-intercept for this one. So if I subtract the x, that gives me 2y equals negative x plus 6. Divide everything by 2, and that gives me, I'll write it down under here, y equals negative 1/2 x plus 3. Remember, the reason why this is negative 1/2 is because this is a negative 1x. Negative 1 divided by 2 is negative 1/2. So its y-intercept is 3, its slope is negative 1/2, so we're good to go. So I'm going to graph the purple one here, y-intercept at 3, slope of negative 1/2, so down 1, right 2, down 1, right 2, down 1, right 2, or up 1, left 2, up 1, left 2. So here's that top line. Okay, now the green line that I did here, we had a y-intercept at 0, 3, and we had an x-intercept at 6, 0. What do you know? Both of those points are on the line I already graphed. So if I connect them, I get the exact same line that I already drew. When this happens, same line means that there are infinitely many solutions. Infinitely many solutions. There are some Algebra 1 teachers who have taught you, and I just know from students in the past, to say all real numbers. That is actually not correct. Do not say all real numbers, because it's not any number that we want. It's only the numbers that are actually on this line. So there are an infinite number of them, but I can't just pick any point that I want. So there are infinitely many solutions, which obviously that's not something I can plug in and check. It just means that they're the same line, but you can pick any point on this line to plug in and see that it works in both. For our classifications, it does have solutions, so that makes this consistent. And because it's consistent, we choose the second, which means it's dependent. So consistent and dependent. All right, last one. So let's go back to our red here. X minus y equals 5. This one we definitely should do with slope-intercept because the y doesn't have a number in front. So that makes it pretty easy to do that way. So if I subtract the x first, that gives me negative y equals negative x plus 5. Then I divide everything by negative 1, which gives me y equals x minus 5. So slope of 1, y-intercept of negative 5. Then let's grab my blue here. This bottom one, I'm going to do a double intercept for again. So if I choose my x-intercept, that means make y 0. So 2x equals 9, which means x equals 9 over 2, or 4.5. So 4.5, 0 is my x-intercept. Then to find my y-intercept, I'm going to plug in 0 for x. So 2 times 0 minus 2y equals 9. So since this is a 0, I get negative 2y equals 9, which, when I divide by negative 2, gives me y equals negative 9 halves. So 0, negative 9 halves, or negative 4.5. So everything does fit. So this is my y-intercept on my blue line. So negative 4, 1, 2, 3, 4.5. There's the y-intercept right in the middle there. And then positive 4.5, 2, 3, 4.5 here. And so connect the dots. There's my blue line. My red line had a y-intercept of negative 5. Which which is right down here, just below. It looks like they're touching there, but they're not. Remember, this is -4.5. And then it has a slope of 1. So up 1, right 1. Up 1, right 1. Up 1, right 1. All the way up the graph. Now notice, of course, it's going to touch on the arrow there because that was really sloppy. But notice that on these entire lines, all of those points that I'm drawing, the red line is just below the blue line and they're not touching. Hopefully you recognize these as parallel lines. And in Algebra 1, you learned that if a system's graph is parallel lines, that means that there is no solution. Because again, the solution is represented by the intersection point. So lines that do not intersect do not have a solution. So that's our answer. And then our classification means it has to be inconsistent for that one. So these are the 3 situations that we can have. There are no other situations. When we have a system of 2 linear equations, they can intersect everywhere, which means infinitely many solutions, meaning they're the same line, or they can intersect once, where you have an ordered pair, XY solution, or they can intersect not at all because they're parallel lines. All right, that sums up our graphing. Hopefully that seems familiar for you.